All right, this is our lesson 9.1b. What we're going to do now is learn how to take the inverse of our trig functions. So the trig functions, such as sine of x, they will take an angle as inputs. So I can say sine of 30 degrees, for example, and the output of that will give me the ratio of the sides. So if it was sine, it would be the opposite over the hypotenuse. So when you use your calculator, when you take the sine of an angle, what my calculator gives me is the ratio of those two sides opposite over the hypotenuse. Okay. Now the inverse trig functions, okay, and they are located, if you look at your sine, cosine, tangent keys on your calculator, above it is your sine inverse, cosine inverse, tangent inverse. That is a second function key. They will take, this is what sine inverse looks like of x. They take the ratios of the sides as inputs, and they will give you the angle as an output. So let me give you an example. Here's a 30, 60, 90 triangle. I've labeled all the sides. I have 1 across from 30. I have square root of 3 across from 60, and 2 is my hypotenuse. So, for example, if I had the sine of 30 degrees, I know that that is the opposite over the adjacent hypotenuse, 1/2. Well, let's pretend that I didn't know the angle 30 degrees. So here's this angle theta question mark, but I knew this ratio of the opposite of the angle in question over the hypotenuse, and I want to know theta. So now I'm going to use my second function key, sine inverse. This is how we undo this sine inverse of 1/2, and the output that the calculator will give me is the actual angle. Okay, so this allows you to undo a sine, cosine, tangent, and so forth. Okay, now it is again important that your calculator is in the correct mode, and we are in degrees right now for this Algebra 2 class. If you don't have it in the correct mode right now, you will get the incorrect answer. This box, I'll let you go through and look at it yourself. We have the inverse sine, cosine, and tangent, and just telling you that the outputs of an inverse sine, inverse cosine, inverse tangent is the ratio, is the angle that's associated with those ratios. So let's find how to use inverse sine and inverse cosine and tangent functions to solve for the questions at hand. So notice now I am asked to find x, and x is the actual angle. And so I know what about the angle? I know its opposite side, and I know the hypotenuse of that triangle. So I'm going to have to pick a trig function that has something to do with opposite and hypotenuse. And hopefully you see, based on SOHCAHTOA, that is sine. So sine of x is equal to the ratio of the opposite, which is 4/6. Now I've got to find x. So I have to undo sine. And how do I do that? Essentially, I will take the inverse sine of both sides. And so this would be inverse sine. And that will undo my sine on the left side. And on the right side, I will get sine inverse of 4/6. So now the input is the ratio, and the output is the angle in whatever mode you're given. So we will plug that into our calculator. Please practice this. So the keystrokes would be, I would actually hit second function, and then I will put 4 divided by 6. I will close my parentheses, and you will get, and we're rounding to the nearest tenth, 41.8 degrees. There is the value of the angle x. All right, here is the next problem. I have some angle x I'm trying to find, and what do I know about it? I see that I know the adjacent, and I know the hypotenuse. So what trig function has something to do with the relationship between adjacent and hypotenuse? That is cosine. So we know that the cosine of x is equal to the adjacent side over the hypotenuse. So we will have to use the inverse function to undo that cosine, and we have to do it to both sides, and we will end up with the inverse cosine of 8/13. And if you plug that into your calculator, you will find that to be 52.0 degrees in rounded to 1/10, or to the nearest tenth. All right, let's do another one. I have x is my angle. I see that I know the opposite side, and here's my hypotenuse, so be careful. And so this is my adjacent. And so I have the two sides that I know are adjacent and opposite. What trig function relates that? And that would be TOA. And then so tangent. So tangent of x is equal to the opposite, which is 11/14. I got to undo that tangent so I can find that degrees, and I will take the inverse tangent of both sides, and I will get the inverse tangent of 11/14, and that will equal my angle. So if you plug that in, you will get 38.2 degrees. Okay, why don't you try one yourself? Pause your video. Welcome back. I want to know the angle x. Be careful. This is the hypotenuse. Therefore, this is the opposite side. I don't know the opposite side, but this is the adjacent side of that x. And so the two sides that I know related to that value x, the angle that I'm looking for, is adjacent and the hypotenuse. So that will be ca for cosine. So I know that cosine of x degrees is equal to the adjacent side, which is 5, over the hypotenuse, which is 8. So I'll take the inverse cosine of both sides to undo cosine. Cosine inverse of 5/8 will give me my angle, and that will equal 51.3 degrees rounded to the nearest tenth. All right, moving on. We must understand when we have problems, communication of what they're discussing is important, and they will use terms such as angles of depression and elevation to describe angles. So the angle of depression is measured with respect to the horizontal going down. So if you're told, in this case, I have a person, and here is the horizontal, and if I'm told the angle of depression based on their view, I would go down, and there is the angle of that depression. In similar fashion, they might use the term angles of elevation, and it is measured with respect to the horizontal, except this time I'm going to go up. So I have to know my horizontal, and if I'm told the angle of elevation from his eyesight, I am going to find the horizontal and go up, and that will give me the angle of elevation. Now, we're going to do some problems that will involve some critical thinking, and this is very similar to types of problems where we're applying our knowledge of math to real scenarios, and there's no way to do this without drawing pictures. If you can't draw the picture properly, you probably won't get the problem correct. So you must take this word problems that we have and draw pictures. So let me give you an example. I have a pilot in a plane. He will be landing on a runway that is 500 feet above sea level. The angle of depression to the runway is 20 degrees, and the elevation above sea level reading in the cockpit is 2,000 feet. What is the air distance that the plane must travel before landing at the runway? So we have a plane. So let's draw a plane. Okay, so here's my plane. They're going to be landing on some runway. So draw a runway somewhere. So here's my runway. And they have told us that the runway is 500 feet above sea level. Okay. The angle of depression to the runway is 20 degrees. So what are they telling you? This plane has an angle of depression to the angle of depression to the runway. So here's the person in the cockpit. There's the horizontal, the angle of depression to the runway. So if I were to draw a line to the runway, I'm being told that this angle is 20 degrees. Okay. They also tell us that the elevation above sea level reading in the cockpit is 2,000 feet. So the inside the cockpit, if I have been told that I'm above the sea by 2,000 feet. Now the goal is to find right triangles to solve these problems. So we are asked for what is the air distance that the plane must travel before landing. That is the distance from where it is to where it starts to land. And here's where it starts to land. So what we want to know is this distance right here. Okay, so we need to construct a right triangle that includes that. So hopefully you see that here would be a good location for a right triangle. Well, there's the right triangle that I'm going to use to solve the problem. Now, do we know anything about, all I need is two pieces of information of a right triangle, and I can solve for the everything else. So this 2,000 feet is that total height. So hopefully you see that I know this is 500 feet. And I can take 2,000 minus 500, and now I know this side of the triangle is 1,500 feet. Do I know any angles of the right triangle? Well, if I know this is 20 degrees, I'll call that theta. Using knowledge of geometry, these two lines are parallel with one another. Alternating interior angles, if that's theta, then I know this is also theta. That's one thought you can use. What is another way we could solve for an angle within the triangle? Well, I know that these two angles add up to 90, and so I know this interior angle is 70, which will make this angle over here 20. So there's more than one way to figure out your angles within the triangle, but this angle will end up being our 20 degrees. Alternating interior angles to two parallel lines are equal to one another. Or you could have found this to be 70 degrees, and then you know the other one's 20. Doesn't matter which angle, I only need two pieces of information. I now know one of the sides, and I'll use 20 degrees. That is two pieces of information. Now I can solve for anything I want in a triangle. So what am I looking for? I'm actually looking for the hypotenuse. And if I use 20 degrees, what do I know? 1,500 is my opposite. So what sign, what trig function has hypotenuse and we'll call this hypotenuse x? Well, that would be sine. So sine of an angle is equal to its opposite over the hypotenuse. So sine of 20 degrees is equal to the opposite, which is 1,500, over the hypotenuse x, which is what we're looking for. We can cross multiply and we get 1,500 over sine of 20. And if you have your calculator in the correct mode, that will end up being approximately 4,385.7 feet. They probably, well, anyway, didn't tell us what to round to, so I have one decimal point. Okay, pictures are critical in these problems, by the way. All right, from a point 50 feet from the base of a tall building, you measure the angle of elevation to its top as 70 degrees. What is the height of the building if your eye level is 5 feet above the ground? Okay, let's draw the ground. Let's draw my building. Okay, so here's my building. I got some windows. All right, here's the person standing. We were told that from the point 50 feet from the base, so I now know this distance. This is 50 feet. They told us that our eye level is 5 feet above the ground. So up until his eye is 5 feet. And although it wasn't clear, but if we measure the angle of elevation from where I'm standing, where is that elevation? So here's the horizontal that I see. And I am going to measure the angle of elevation to the top of the building. So let's draw a picture to the top. And there is my angle of elevation, which is above the horizontal, and that is 70 degrees. Okay, let's just go ahead and draw this dotted line all the way over. And notice that is the same distance as that 50 feet. Now I know two things about that triangle. If I know two, I know everything. If I find this height X, and then I can add to it that 5 feet, and now I know the height of the building. So what is X related to that 70 degrees? That is the opposite. And what do we know about that 50? That is the adjacent, because this is my 90-degree angle, therefore this is the hypotenuse. So the two things I know with respect to that angle is the adjacent, and the opposite is the one I'm looking for. Adjacent and opposite, that is not ka, that is toa. So I know that tangent of 70 degrees is equal to that opposite side over the adjacent side. Okay, I need to find X. So cross multiply, X is equal to tangent of 70 times 50. X will be equal to 137.4 feet. That is not the height of the building. I have to add 5, and then I will get the total height of the building as 142.4 feet. Okay. A 15-foot ladder is leaning against the side of a house. Here's my house. Here's the ground. And here is this ladder. How long does the ladder? It said 15 feet. The ladder is 15 feet. The top of the ladder is 13 feet off the ground. They just told me this height or this length is 13. Find the angle of elevation. Elevation from the horizontal. Here's the horizontal. This is the angle of elevation, and this is theta. Theta equals question mark. I'm now trying to find an angle. What do I know about that triangle with respect to that angle? I know the opposite side, and I know the hypotenuse. What has to do with opposite and hypotenuse? That is sine. So we know that sine of theta is equal to the opposite side over the hypotenuse side. Sine of theta is equal to 13 over 15. Now I got to find theta. I have to undo sine. So how do I do that? I take the inverse of both sides, the inverse sine of both sides. That will get rid of my sine function on the left, and I'm left with inverse sine of 13 over 15. And I will find theta. That will be second function sine, and then you'll hit 13 divided by 15, and then you'll close your parentheses, and assuming you're in the correct mode, you will get the answer of 60.07 degrees. Your mode should be in degrees. All right, let's have you try one on your own, and then that'll be our last problem for the day. Welcome back. I have the top of a lighthouse that's 150 feet above sea level. In the distance, there is a ship which is 2,000 feet from the base of the lighthouse. What is the angle of depression from the top of the lighthouse? So here is my water. Here is my water. Here is my lighthouse. Okay. I have somewhere out in the distance a ship. Okay, there's my ship. I have been told the top of the lighthouse is 159 feet above sea level. So here is that height. In the distance, there's a ship that's 2,000 feet from the lighthouse. And they want to know the angle of depression from the top of the lighthouse to the ship. Angle of depression. Well, here's my horizontal. And what to where from the top of the lighthouse to the ship. Now there's my length or my line. And where's the angle that they're asking for? Angle of depression is from beneath the horizontal. So they're asking for that theta right there. And I have a triangle and that theta is not in that triangle. But based on some previous knowledge, this is parallel to the sea level, alternating interior angles, parallel lines, there's theta. The other way you could do that is theta plus alpha is 90 degrees. And then I know this side over here is theta as well. So we're going to use theta. That's what I've been asked for. And now it is within my right triangle. I'm asked for theta. Well, what's 159 with respect to theta? That is the opposite. And what's 2000 with respect to theta? That is the adjacent. Opposite and adjacent, what trig function has something to do with opposite and adjacent? That would be tangent. So tangent of theta is equal to the opposite side over the adjacent side. Tangent theta is equal to 159 over 2000. I got to get theta all by itself. I need to undo tangent. I'm going to take the inverse tangent of both sides. That gets me theta by itself. I have inverse tangent of 159 over 2000. Theta will equal 4.55 degrees. And that is the angle that I'm looking for. You could have solved for this alpha and used trig functions for that. And then you would have had to subtract it from 90 to make sure you gave the answer for the actual angle they were looking for. All right, hope that lesson makes sense. I'll see you in our next video.